welcome everyone this morning. I'm pretty excited. I'm well caffeinated, so let's dig into this and have some fun. All right. So, like I said, welcome to the presentation. Today, we're going to talk about leveraging Postman for some security testing. Particularly, I'm going to go over two examples. One is going to be defensive, so some auditing and compliance checking kind of stuff. But probably what everybody's really interested in is the second, which is being offensive in order to test that. So let's go ahead and let's get started. All right, as I said, my name's Ryan, at least that's what my mom tells me, and I've been working in security for about 15 years. I'm the co-author of AWS Detective, as well as a published author on threat hunting and incident response. But probably the biggest question here is, why should you care? So over the last 15, plus years, I've broken a lot of things, and I've had to secure a lot of different environments with different technologies in it. And where it always comes back down to is defining that problem. So here we're going to start off with what's the problem? What are we trying to solve? And the honest answer to that is, well, a lot. But very particularly here, we're going to be trying to go through some of the shortcomings of the existing tooling for us to try and meet, compliance standards or to ask questions and interrogate our infrastructure. So things like, how do you audit IAM, and what do you audit for? Are you even asking the right questions? All right, the biggest issue we need to solve in the short term is how to have repeatable, consistent notification of basic compliance across the AWS IAM best practices, right? And that's pretty targeted for this talk because we only have a few minutes to talk about things. But let's work our way backwards, right? First, we need to define what we're actually auditing for and what is and isn't an acceptable answer to that question. For this, I'm going to run a very chosen and practiced, well-used standard from AWS, the best practices standard, which actually is a fork of the CIS AWS controls. CIS is the Center for Internet Security. They're very well known for setting standards across a bunch of different technologies. So AWS and them, probably work together on it, but in the end, they forked and created their own customized version of it, which is kind of cherry picked from the larger selection of CIS controls. The AWS best practices are chosen by like AWS architects and security engineers. So they're people that are actively working on securing production environments for their customers constantly. This kind of best practice standard is going to include things like, turn on MFA, to a lot more complicated things like monitoring activity in your account. So since some are objective and some are subjective, we're only going to have time to cover the objective best practices. So I highly suggest you check out the actual document, check out the security architecture collections, and update them to kind of meet your needs more. So apologies for the wall of text, but I wanted to really kind of give you a sense of scope here. This is how many things this collection is going to audit. Now, one thing to remember is this collection is already public. So you right now can go to Postman and download this collection, import it into your environment, change a few variables, and boom, you're ready to start doing some of this auditing. And that's one of the things that we really want to kind of show is how easy it was to audit multiple environments with this and things. So how does Postman Audit Collection really compare to the best practices? Out of the box, there's 9 controls and report results for non-compliant resources. So not all of the controls are in here, but once again, we're focused on the objective ones that we can kind of cover in 25 minutes or so. And you can run the script against all of the AWS accounts in your organization, as well as different regions, stage, beta, production, however you break it up. So how's that collection actually work? Well, very carefully, and I'd like to say with 30% more love than our closest competitor. But outside of that, the collection makes use of REST APIs exposed by the AWS IAM service to fetch data related to IAM entities and access to AWS resources. The collection process fetched data using a pre-request and post-request test to detect that non-alignment really between the current state of the AWS resources as well as the desired state, which we're having the audit checklist. Now, the audit result is then pushed to Slack for further action for the DevOps team. So what we're really doing is we're collecting a lot of telemetry, and we're using context to take that raw telemetry and convert it into actionable intelligence, which allows us to do things like create tickets for actual steps of what needs to be done, to remediate things, to even being able to create triggers for automated remediation if you so see fit. So to access the collection and import it into your workspace, you can find the collection link on the reference slide at the end of the presentation with a bunch of other references. For example, we're going to have references for how to create the IAM, they're called the AKID tokens, but they're basically your API keys, your access keys for AWS to run these types of queries after you've authenticated. Also, how to create a Slack webhook URL. I made sure all the links are in there, so really all you need are the links at the end of this presentation. Read through the top 3 or 4, and you can recreate this yourself in a couple of minutes. So now that we've gone through the step of kind of importing that collection, the first thing we need to do is create an environment for it. And environments in Postman allow us to store credentials or other variables to be used by our requests in our collection. So this was incredibly important to me, particularly because I can create multiple environments easily, say credentials for stage, credentials for beta, credentials for production, and reuse the same request code or the same collection and just change that one environment. And now I've gone from testing in stage to actually auditing production really quick and easy, and allows me to reuse a lot of the work I've already done. So probably the biggest thing that you can take from that, besides the usability of it and kind of that fun user experience, is you don't have to hard code credentials in your requests. Please never hard code credentials in your requests. It just makes everyone a sad panda. And one of the great things about the environments is that you have your initial values and your current values. So initial values are shared when you share a collection or an environment, but current values are local and they're not synced or shared. So that way you can have kind of a template as your initial values, that when you share the collection with people, they'll be able to see examples, but not have legitimate keys in there. And you can use the current values to actually have your keys, and that way you're not sharing private information, right? You do not need to see my credentials, all right? So once again, I've included those links to how to create those webhooks and the AWS access keys, so that way you guys can go ahead and just start using this pretty quick. So now that we have the credentials populated, we want to run the collection. So I do the most complicated thing ever and click the button that says run. So with this, we're brought to the run order. And the run order is going to be defining which order the requests are in. So you can either prioritize them and it runs kind of down the stack, or you can use something called like next request, which is a variable that actually allows you to choose which request to do next in order. So I use things like that to create request loops. If you check out my talk from yesterday going over how to do integrations between 2 SaaS products, you'll see us using that technique to actually create request loops and be able to go through a large list. In this case, we want to run the entire collection, right? Because we want to audit all 9 of those things. So we're going to sit here and we're going to click on the Run AWS IAM and Organizations Audit button. Why? Because that button's text changes depending on the name of your collection. So if you name your collection Batman, it's going to say Run Batman. And if you run Batman, expect Gotham to be very happy. Now, we're going to play the waiting game, right? And after a few seconds, we're going to see the run progress of each request in the collection. Once again, not too bad that we only had to make 3 changes to our environment after importing the collection, and we're ready to run an audit. And you'll know immediately whether or not you were successful with creating those credentials because you'll see failures by the requests. So that's good to know. You get that instant feedback. And once again, you can go back and, RTFM and actually figure out, what happened if you broke something. But what we care about here isn't so much that the collection ran successfully, right? In this talk, we want to talk about what we're auditing, why we're auditing it, and what can happen if people abuse your environment and why we're doing those audits. So for the curious few, here's the console output from a successful run. As you can see in there, there are some actual users that have been left in there. This is actually one of my personal AWS accounts that I ran to create the detection lab, the detonation lab that we use to build some of AWS Detective. And I deleted this account now, but you can see there's some old users in there. There's users that don't have MFA. There's some old tokens. I basically chose it because it's an abandoned site and it had some bad practices. But you can see these are the things that it's actually auditing for, and it's finding results. And then it takes those results and it sends it, in this case, to Slack. All right, because now that I've audited and I've found non-compliant resources, I want to make it somewhat actionable. So in this case, we're using Slack to really just notify users. So we're using that Slack URL to send it to a specific room or specific Slack channel, and which is great for when you have a smaller environment. But as you grow for larger environments, you'll probably want to change that Slack notification to something like push this to Ops Genie or whatever workflow ticketing system you have to remediate issues, Jira or whatever. And then at that point, you can actually start creating those tasks that need to be remediated. So once again, what are we actually auditing for? Does anybody remember? All right, I'll give you a hint. It was on slide 6, but in case you forgot this, like a normal human would, especially it's only 8:40 in the morning right here, Eastern time. So what we're going to look at is the full list of attributes and controls. So once again, that entire collection has these 9 controls. We went through, we quickly populated some credentials, we ran it, we were able to get results. We could see that I had non-compliant resources. That's an awesome single time run. But like with most auditing, you want to have continuous compliance or some kind of continuous auditing so you can see the state of your environment the entire time. Right? So we need to operationalize it. We need to have this be repeatable easily. And one of the big perks that I found as I was learning more about how Postman worked is that with collections, I can do these things called monitors. And monitors allow me to have the collection be run in certain intervals or frequencies, which is what I desired for my outcome. So here, to create a monitor, it was pretty easy because all I had to do was click those 3 dots next to the collection name and then select monitor collection. I know that's a real struggle to get to. I had problems with it too. So afterwards, you're prompted to populate details about the monitor. So name it something you like, but make sure it's descriptive enough to remember. That's always the best practice for me because in 2 years when I go back to it and I have no idea what it is, I like to have some idea or some context from the name. Then I choose a frequency. The frequency is going to be specific to your environment. If you have a highly dynamic environment, so something that with multiple admins, something that's constantly spinning up, users or systems or things like that, you probably want to have it run more often, so that way you catch non-compliance items more quickly. If you have more of a static infrastructure, you probably don't need to run it as often, but it doesn't hurt to audit extra. So for this example, I'm going to run it every 5 minutes. And the reason for that is because I really wanted to fill up a graph and I didn't want to wait forever to do it. So what does our graph actually look like? These are all the points of time that I ran it. So as you can see, I ran it for, I think like 30 minutes or I ran it for close to an hour. And what that tells me is that this is constantly being run, the collection's going out, it is getting the resources. I'm able to click on any of these runs and go actually into it and see the console output. And probably my favorite part about this is that little green thing at the top that says healthy, because it tells me that it's alive, right? This is going to start working. Now I've operationalized this, but I've been able to test, I can authenticate successfully, I can audit, I can pull that details, but what does it look like now that it runs every 5 minutes? And what it's doing is it's populating that Slack channel. With every run, you have the output going. So this is giving me a repeated list of things to remediate, and I kind of have the choice. Do I start opening tickets? Do I work with the Slack stuff? But either way, once you have been alerted for these non-compliant resources, you can go ahead and start to remediate, right? We want to be able to take that information that we've collected. We have context to it. We know what audit had the non-compliant resources, and we can probably pretty quickly and easily from the best practices document go through the steps of how to actually remediate that non-compliant resource. So now that we've kind of gone over I'll call it the defensive side. It's really, the audit and compliance and things like that. But why do we care? Why do we even want to do this auditing? What's the risk if we don't do it? So I don't know about you, but I like to test my alerts and make sure that my auditing's working. So we're going to do some bad things, and we're going to validate the alerting works. Right? Who likes breaking stuff? So I'm going to recreate some known TTPs. Those are tools, tactics, and procedures, also known as the heuristic kind of version of IOCS, the indicators of compromise. And I'm going to run this in my environment to see if I can catch any of this with my new audits. This coincidentally also mimics a real-world attack, no relation. I want to learn more about Postman when I started this. So what I did is I took a test that I commonly use to test AWS infrastructure and some of the security tools, and I turned it into a Postman collection. So that was my kind of learning thing of I know how to do this in Python or Bash, AWS CLI, things like that. And I wanted to translate it to Postman so I could learn what the equivalent is there, not just syntax-wise, but also workflow-wise. Now, this tool, this attack, this technique is also used by tools like Pacu and things like that. So this is a known attack. This is a known method. There are already guard duty findings for it, and I very much made sure that I only chose things that have been patched and protected already. So what we're doing here for the attack workflow is we're going to initiate a web request to exploit an SSRF vulnerability. That's a server-side request forgery. I'm running a vulnerable PHP server with Apache on an EC2 instance. And the EC2 instance has attached to it an overprivileged instance profile. Now, these are two requirements of the attack. First is, a vulnerable web server. And the reason for that is I need a vulnerable web server to gain RCE, which is remote code execution, something that allows me to run commands or execute binaries on the victim system. The second thing that I needed was an overprivileged role attached to that instance because I need to abuse those privileges. Now, auditing for privileges on roles that are attached to instances are incredibly important. Everybody's kind of gone through this scenario. You're working in DevOps. You know that you have a release that needs to come out. The runs keep failing for whatever reason due to permission issues. So, you got the boss breathing down your neck. You need to release this right now. So you basically just say, all right, give it admin, give it God mode to run so we can push out right now and make sure it works. And then we'll go back and we'll limit the privileges as needed. And then nobody goes back to limit the privileges as needed, right? So we'll find some of that with audits. But for this case, say they're not auditing and they did something like this. So once I've exploited that vulnerability in the web server, and I start running commands local on the host. I'm going to do some local system recon, find things like users logged in, passwords, things like that. But then I'm also going to exfiltrate the credential metadata from the instance and start running commands against AWS, assuming all the privileges of that role. So I can actually start taking over the entire AWS account from it if I wanted to. But the proofs that I'm going to use, I'm going to create some persistence mechanisms. So I'm going to do things like create an SSH key and a new user and spawn an EC2 instance with like a Bitcoin miner on it. So that way I can make some money. Now, things to remember in this is, we're abusing older things. And I chose this on purpose because, one, I don't like to get sued. And two, all of these things have been patched or have compensating controls. So things like the SSF vulnerability, that was patched 15 years ago. It's a common CTF flag exploit. So you won't see it very often in the wild, if at all. The way that we're going to exfiltrate credentials has been fixed by using the metadata v2 service on your EC2 instances, things like that. So now that I've gone over this at a high level, pitter patter, let's get at her. The attack collection. So since I created a collection of all the requests I'm using, basically I have about 16 stages with this attack. I've commented out a few things here and made the text pretty small on purpose because I don't really want to tell people how I'm attacking a legitimate infrastructure. But you can see here that there's a successful run of the collection with all 16 stages being executed. So let's dig into kind of what we just did and why we did it. First, you can see that I used that really old SSRF attack via GET request to the PHP server to find out what the instance profile is. Have no fear. Once again, the attack was patched 15 years ago. It's a standard beginner CTF flag. Every IDS everywhere should have something for it. Basic things like that. But let this be a lesson to you. Always sanitize your data input. We could have a compensating control here where we filtered data input before it got to the web server, and we wouldn't have to worry about an attack like this. So now that we know what instance profiles attach to the instance, we're going to query the metadata service and get the temporary credentials of the user. It's pretty nifty, but if you don't want it to happen to you, once again, enable v2, and you won't have to worry about this kind of activity. Once again, also don't install vulnerable software and constantly audit for things like that, and you won't have to worry as much. Security is a process. There is no end to it, so constantly iterate and improve. While you're here, we want to do some local system recon. So what I was able to do is get a list of the users. So through this exploit, I have the ability to do remote code execution. So I basically said cat Etsy shadow or Etsy password, and you can see that up on the screen. I was able to do that. I could run, a W command, ifconfig, kind of anything like that I want that I have privileges for. The restriction here is how many privileges does the user that I'm abusing have. And the way I can tell that is through this exploit, I'm running all these commands through the user that runs the web server. So in this case, it's the Apache user. So if you go onto your host and you look at the Apache user and what privileges they have, that's what I can do. So locking down the users that you're running, web servers and things like that under is also a good idea, because then, even if I do exploit you, I have a very limited amount of commands that I can actually do from there, and I'll have to find a second exploit to, escalate my privileges or something like that. So there's a lot of other things I can do, but we only have 25 minutes, and I really need to hop through. So what about a little persistence? Well, this is me leveraging those stolen credentials, the metadata credentials, which allow me to run things as if I was the user that is attached to the profile of the instance, so the AWS user. And with that, since we know it's an overprivileged role, right now, I'm going to create an SSH key, a new user, a new EC2 instance, and basically anything else the instance profile has permissions to do. If it only had permissions to read and write to an S3 bucket, I can read and write to an S3 bucket. I'm basically assuming that role in context. So with this and the abuse that I'm doing right now, with all the bad stuff, would we ever see any of that? Would we know about it? Well, yes, we would. Guard duty already has detection for this kind of activity. So once again, this is why one of the reasons we did this is that we know that it's going to be flagged. We know this activity is going to be seen. I know this because I tested this for when I helped write Detective and also contributing to the other security services. So like we know how to do this testing. We know that this is going to fire, but for this talk, we don't care so much about AWS detecting it as much as we want to see things like this in our audit, so that way we can proactively stop the ability for attackers to do these things. And with that, we're doing the audit. So with our audit, would we have been able to catch this? Yes, we definitely would have. Audit number 8, the identify all permissive policies attached to roles, looks for those permissive policies and finds the overprivileged roles. So the instance profile that is attached to that EC2 instance had over permissive policies attached to it to allow it to, get the job done. So we're going to see that in our collection run. Now you can customize each one of these collections and requests, even add additional requests to check specific things for your environment. Every environment's going to be different. It all depends on who set it up, what standards they adhere to, if any, and how much turnover you've had and things like that. Environments grow organically. So we have standards of these audits to see what services and resources are meeting our bar and which ones aren't. So I don't know about you, but this collection's been a pretty big life changer for me because I'm able to internally customize this audit script, this audit collection to go through and made it a core part of our continuous AWS auditing here at Postman. What's publicly released is that 9 version collection. We have a more customized one internally for things that are specific to our environment that wouldn't make sense to audit for in everybody's environment, just because you don't want to break random things. It's the equivalent of you have 1,000 hungry people. Well, let's give them all a Snickers because they're hungry. Great. Now all 1,000 people are no longer hungry, but 200 of them are dead because they had a peanut allergy they weren't aware of. That's what we're trying to avoid with like any kind of automated remediation, right? We don't know what you have, so therefore we only want to use these non-invasive controls when we share it, so that way we don't accidentally break something for you. So with all this information, want to kind of test it out. If you're new to the Postman and you just want to kind of try this out, one of the cool things that I've recently learned about more is public workspaces. I am not a Postman SME. My usage of it is the equivalent of opening a pickle jar with a sledgehammer. I'm going to get the jar open, but it's not going to be pretty. So one of the things that I started doing is I actually started going through some of the training courses we have publicly available to see if I can improve my Postman ability. So these public workspaces are great because you can easily get started. You just got to sign up for that account and you can browse the existing workspaces. So you can import this collection right into there and get started learning about it and actually functioning with it. And one of the other resources that I spend a lot of time on is learning.postman.com, because that allows me to go through existing documentation about these features and actually figure out how I can apply them for my use cases, right? Because I'm going to define my use case first, then I'm going to figure out how to do it. So with that, I want to thank you all for your time. I remember my motto: flag it, tag it, and bag it. And basically, I'll sit around for any questions. And here is the reference slide I'll leave up while we do questions so people can see all the links that I was referring to and get this going on their own.
Thank you, Ryan. That was a really fun talk. And we will definitely flag it, tag it, and bag it. So for all the attendees, Ryan will be answering your questions directly in Slido. And we will be moving on. So thank you so much, Ryan, for this really wonderful talk.
Thank you very much, guys. Have a great one.